Alright guys, we got section 3-1, which is parallel lines and transversals. The objective here is to identify the relationship between two lines or two planes and name angle pairs formed by parallel lines and transversals. So you'll see that this section is very vocabulary driven, but don't take that for granted because you're going to find that a lot of this stuff is going to become increasingly important as we move forward. We're going to use all these definitions to solve problems and later on do proofs. So make sure you get this vocabulary down, okay? So if you need to, pause the video, go back, reread some of them, listen to what I say again, and really learn this vocabulary. Don't take it for granted, all right? So vocabulary. So the key concepts. Parallel lines. We know what parallel lines are. We've talked about them before, right? They're coplanar lines that do not intersect. So here we see JK and LM are parallel, right? So we all understand that. Skew lines, that's new to us. And they are lines that do not intersect and are not coplanar, okay? So you can see on here that line L and M, see they're on different planes and they do not intersect, so therefore they're skew, right? And I'll have a few more examples on the next slide of those. And then the next thing is parallel planes, and that again we've talked about, right? Parallel planes are just two planes that do not intersect. So you see the two planes here, A and B, they do not intersect, they run parallel. So you understand that. Let's talk a little bit more about these skew lines, right? So skew lines, remember, they do not intersect and they're not on the same plane. They also can't be parallel, right? Because if they're parallel, then you can draw a plane through them, so therefore they're kind of on the same plane. So an example of some skew lines would be line AB right here and line CG would be good examples of skew lines because they're not parallel, they're not on the same plane, they do not intersect. Therefore, they're skew, okay? And that's not only on rectangular prisms or planes like we looked at last time. Right here we got a nice piece of cheese, right? And you can see that KL, this line here, and PR are skew lines, right? Because again, they do not intersect and they're not on the same plane. Alright, so that's skew lines. So next, we got these transversal things, right? This is called parallel lines and transversals. So transversal is a line that passes through two lines in the same plane at two distinct points. So if you see here on this example transversal here, you got the two parallel lines running horizontally, and then you got the transversal, and the transversal cuts through these two lines, right, and it touches them at 2 points, okay, and it creates a bunch of angles that we're going to learn a bunch of vocabulary and later on properties about, okay? So then I got another real world example here. So I pulled up a map, and it's right here at our good old Clearbrook, right on the quest for the best. If you look, every single day I drive down 2351 to get here. Well, 2351 is actually a transversal because it cuts this street here and this street here. It cuts across it, and it hits it at two distinct points. So we can actually say 2351 is a transversal. All right? All right, so now we got to talk about the angles that these transversals create and name some of them. So you just got to pay attention to this vocabulary, guys. It's going to be important, so we got to know it. I promise, okay? So look at some of these guys. So the first one is interior angles, and interior angles lie in the region between lines Q and R. So if you notice, we got lines Q and R, right, these two lines, and they're cut by a transversal. See, it hits the two distinct points. That's how we know it's a transversal. You notice how it creates these two exterior regions and then an interior region? Notice the exterior regions are in blue in this picture and the interior regions are in green. So that's why the first one we got interior angles. So that's just going to be the angles that are inside that interior green area. So 5, 6, 4, and 3. Okay? And then Vice versa, we got exterior angles, and those are the that lie on the outside of Q and R, on the outside of our two lines that are cut by the transversal, so in the blue areas. Okay, so exterior angles in this case would be 1 and 2 and 8 and 7, right? All right, so now we got a couple of different things. We got consecutive interior angles. Are interior angles that lie on the same side of the transversal. So when it says the same side of the transversal, it means T, right? The thing that cuts it, the transversal is where it cuts and touches at two distinct points. So, and then it's consecutive interior. So when you see interior, you know we're talking about this green area right in the middle. And then consecutive just means consecutive back to back. So in this case, 4 and 5, they're on the same side of this transversal, so they're consecutive. They're on the same side of T, so 4 and 5 and 3 and 6 are consecutive interior angles. Okay? And then you have alternate interior angles. And those are non-adjacent interior angles that lie on the opposite sides of the transversal. So when you see alternate, it means alternating on opposite sides of the transversal. So T cuts it. When it says alternate, it means alternate sides of that transversal T. So in this case, and it says interior, right? So we know we're talking about this green area. So in this case, it'll be 3 and 5 and 6 and 4 will be alternate interior angles. Okay? And then along the same lines, we got alternate exterior, right? So again, when we're talking about the exterior, you know, we're talking about this blue shaded area, right? They're on the outside of the two lines, right? So then we got alternate exterior, so we got 7 and 1, right? Because they're on the opposite side of the transversal, and they're on the exterior, so 7 and 1. And then we also have 2 and 8. All right? And then the last one is corresponding angles, right? And they lie on the same side of the transversal, so on the same side of T, right? And they're on the same side of lines Q and R. So they're on the same side of T, our transversal, but then they're also on the same side of the lines that are cut by the transversal. I know that one sounds kind of crazy, but in this case, the angles that are corresponding angles are 1 and 5, right? Because they're both on the left side of T, right? And they're both above their line that's cut by the transversal. Like this one's above R and this one's above Q, so they're in the corresponding position. Okay, and the same thing we got with 2 and 6. They're both on the right side of the transversal, and they're both above the lines Q and R. So 2 and 6 are corresponding angles. All right, and then same thing for 3 and 7. You see how they're both on the right side, but they're both below Q and R. They're on the corresponding position. And then same thing for 4 and 8. Okay, they're both on the left side of the transversal, and they're both on the bottom position. All right. So again, guys, don't take those for granted. Read through these guys again, really get a good understanding. If you need to rewind the video and listen to what I say about them again, do that. Do whatever you got to do, write them down, and really learn those guys, because we're going to use them over and over again throughout geometry. Okay? So now we got the examples. So it says refer to the figure and classify each pair of angles. So the first one they give us is 1 and 5, right? And we see 1 and 5. So let me circle 1 and 5. And so here's 1, right? And here's 5. And we see we're cut by the transversal, so this part right here is our interior, right? And this part right here, the outside part where 1 and 5 are, that's our exterior. And then you see the transversal cuts it. They're on opposite sides of the transversal, or alternate sides of the transversal, right? So they're alternate and they're on the exterior, so therefore they're alternate. And I'm gonna write the shorthand: alternate exterior angles. Okay? Alternate exterior angles. I know I wrote the shorthand, just know that's alternate exterior angles. Okay? So then the second one, 6 and 7. Let's look at those guys. Okay, so 6 and 7. Okay, so Here's the transversal. Always refer to the transversal. They're on the same side of the transversal, right? And then they're both on the interior, right? On the inside of the two lines that are cut by the transversal. They're on that, it would have been the green area on that last example, right? The interior. And then they're on the same side of the transversal, right? So that was called consecutive. Interior angles. Right? Okay. And then the next one, we got 2 and 4. Let's get those guys. So we got 2 and 4. Again, we're looking at the transversal, right? They're on the same side of the transversal, but one's on the interior and one is out here on the exterior, right? So what did we call those? We called them, notice they're both on the same side of their line, though. They're both on the right side or the bottom side of their line, depending on how you look at it. They're both on the same side of the transversal, but they're not in the same. One's in the interior, one's in the exterior. Those are those corresponding angles, right? They're in the same corresponding spot that their line makes. So these are corresponding angles. Okay? And then the last one is 2 and 6. And we've already used 2 and 6, so let's go with a little. I'm going to go with the highlighted color. I don't know if it's going to be overwhelming. So 2 and 6, right? So these guys. So 2 and 6, they're both, again, in the interior, right? They're inside of those lines. And then they're on opposite sides of that transversal, right? Or on alternate sides of the transversal. So we know, real quickly, right? They're alternate interior angles, right? They're the opposite of what number A was. Okay? So pretty straightforward stuff. If you know your vocabulary, again, go back, look over that vocabulary, make sure you're understanding everything we're saying here, because this stuff's going to become important, right? So last, we got a practice problem. I know it's a lot, 10 of them, but it's real quick. Just look at them and define them. Look at them, define them, all right? All right. See you in class.